Alright, we had a false start. We're talking about limits at infinity here, and gave an example of the limit as x approaches 3 from the left of 2 over x minus 3. Now, if we did a direct substitution, we'd find out that 3 minus 3 is 0. We get 2 divided by 0. It doesn't work there. 3 actually is not in the domain of this function. This would be a non-removable discontinuity, which would lead us to say it's an asymptote. But now, as we're approaching 3 from the left, we're coming in towards 3 with our values 0, 1, 2, and then we're getting infinitely closer to this. So, when we're evaluating these types of limits, these one-sided limits, think of when we have a denominator here, think of this idea. Like 2.99999 minus 3. We do this, we'll end up with 0.00001. Now this is a small number. If I were to plug in 0.299999 into this, I'd figure out that we'd get 2 divided by 0.00001, and when you divide by a small number, your answer, well actually, remember that would be negative, so that's negative. So when you divide by a small number, we're going to get a big number. And in this case, in the negative direction. So if I were to say 2.999999, it'd be even smaller, which means if we divide by an even smaller number, we'd get an even bigger number. So we can make this number get closer and closer and closer to 3 by making the difference smaller and smaller and smaller and smaller. Then by dividing by that smaller number, we're getting a bigger negative number. So it's becoming more and more and more negative. And what happens during this is the function is just going and going and going forever, but it's never going to hit that x equals 3. But it's going on forever and going towards negative infinity. So now the limit would actually equal negative infinity. But there's a problem. And the problem is we can't equal negative infinity. We can't equal infinity. Infinity is not a number. So you can't equal a number. So what does the limit as x approaches 3 from the left of 2 over x minus 3 equal to negative infinity mean? Well, 1, the limit actually doesn't exist. There is no limit. 2, f of x is unbound, which means it has no bounds, which means it goes on forever and ever and ever and ever and ever. So it goes to negative infinity. Now, if we were coming in from the right, we'd have like 3.0000001 minus 3, and we get a positive really small number, and we find out that the function is actually going towards positive infinity in that case. So that's the big deal for that. And the third thing is we have a vertical asymptote at x is equal to 3. We're able to tell that from this whole situation. Now, you're going to get different quadratic situations. and we want to make sure, or we're not quadratic, but rational situations. We got to make sure whether or not our function is going to infinity or negative infinity, and things of that nature. So remember, factor, divide out common factors. So factor and divide out common factors. That's a big thing with this, especially when we can remove the removable discontinuities and just focus on what's happening at the non-removable discontinuities. And that's really what we're doing here. We're trying to figure out what the function is doing at the non-removable discontinuities. And since calculus is all about analyzing what the function is actually doing and then applying that to different situations, we have to try to understand everything about this function. And coming up with these types of limits when we have this situation, we won't say it doesn't exist, because that doesn't help us at all. What it does is it shows that f of x has unbound behavior. It just keeps going and going towards negative infinity, and eventually, if we found it from the other way, it'd have unbound behavior towards positive infinity. And that's a big deal when we're trying to graph this by hand and you don't have a calculator. That's what you want to be able to do, is you want to be able to use what you know in order to figure out different pieces of information. So, as you're working through limits at infinity, remember, a lot of it is having to do with factoring and factoring out common factors and dividing them out and figuring out where your asymptotes are, then figuring out what's happening to the left of the asymptote and what's happening to the right of the asymptote. Do we have unbound behavior? Do we have functions going to infinity or negative infinity? And that's really what we're trying to look for in these cases. So, good luck, and if you have any questions, you know where I teach.